Okay, so in this numerical example, which is 14.2, and which is taken from the RC Hibner book, and is one of the numerical example in your tutorial sheet. So the 1750 kilogram automobile, which is shown in figure 1410A, which is this figure here, traveled down the 10 degree inclined road at speed of 6 meter per second. So the speed at location A is 6 meter per second. If the driver jam on the brake, causing his wheel to lock, determine how far is the tire skid on the road. So the you need to calculate this distance S here, so that the velocity at location B here will become 0. And the coefficient of kinetic friction between the wheel and the road is mu k, which is 0.5. So in addition to the weight, we also have the friction force here. So the given data is mass is given. So m is 1750 kilogram. Travel down the 10 degrees inclined road at speed of 6 meter per second. So VA is given. The driver jam on the brakes, causing his wheel to lock. Determine how far is the tire skid on the road, and you need to calculate this S here. And this means that VB will become equal to 0, and the coefficient of kinetic friction will be is 0.5, which is given. Okay, so in this case, you can draw a free body diagram here. So this is our angle theta, which is given is 10 degrees. And if you consider this our car, the weight is in this direction here, and the which can be split into two components. So which one will be normal to this plane and one will be tangent to the plane. So this is our W, and this angle is 10. So this angle is also 10 here, and then this will become W sine theta, and then it will become W cos theta. Okay, so and in this case, in addition to the weight, we will also have the friction force, which will be in this direction here. So this is our friction force. Now to calculate the friction force, we need to calculate the normal to this surface here. So the normal force in this case is this force here, this N here. So if we just take summation of all the forces in y direction equal to 0, because there is no motion in the y direction here. So what we can write that we can say that N is minus mg, and if we take this is our y-axis and this is our x-axis, so N minus mg cos 10 equal to 0. So from here you can calculate N, which will become mg cos 10. So this is our N force here, and from here you can calculate the friction force, which is the kinetic friction force, and which will be mu k into N, so which will be 0.5 into mg into cos 10. So this is the friction force that we get here. Okay, now here we to solve this problem, we can say that the velocity was given here at location A, which was 6 meter per second, and the velocity at B is 0. And we need to calculate this distance here. So as you can apply the here the work and energy principle between A and B. So this is our location A. So if we apply the work and energy principle between A and B, so which will be TA plus VA plus UAB dash equal to TB plus VB. Okay, so in this case, uh, what we know that at location A, we have the kinetic energy, which is half MVA square, and you also have the kinetic the potential energy here. Although there's no spring here, but there is height here, so you can calculate this height here. If you take this is our 0, if we take this is 0, so we can calculate the height of location A, which will be S sine of theta. So this will become mg, and S sine of theta, and in addition to this, then you will have to calculate the because we have now a friction force, so which will do a work. And as you can see, the friction force is against the displacement, so therefore the work done by the friction force will be negative here, so minus, and in this case, if you calculate the friction force, which is this force here, so this will become equal to 8453.35 Newton. So 8453.35 is the friction force, and then because we have to calculate the work done, so the distance here is S, and then on the right hand side, you have TB, which is the kinetic energy at location B here, which is 0 because the body will stop. And at location B, the height is 0. So this is our H. We will take our H equal to 0 here. So height is 0, so the gravitational potential energy will be 0. And there is no spring here, so there is no elastic potential energy. So this is the equation that we get here. So if we just put the values here, so it will become half, and m is given, which is 1750, and this is 6 square, and again 1750, 9.81 into S sine of 10, and then you have minus 845 3.35 into S equals 0. So from this equation, there is S here and S here. This means that there is only one unknown in this equation, which you can calculate very easily. So the result will be 5.76 meter.